Okay, guys, so this is page 5 of your linear functions booklet. It's over transformations. Now, these are the standard notations for each of the transformations of a function. So, number 1, f of x minus h will be your right translation. And that is a horizontal translation. So you put G right here. Number 2, we have f of x plus h. That is still a horizontal translation, and that will be D, is going left. On 3, we have f of x plus k. That is a vertical translation, and you'll put H, we're going up. On number 4, we have f of x minus k. We have a minus k on the outside, that's going down. That's a vertical translation going down, which is A. Number 5, we have negative f of x. That's going to be E. It is a vertical reflection across the x-axis. On number 6, we have f of negative x. So the negative is on the inside, so that is a horizontal reflection. So it would be F, a reflection across the y-axis. On number 7, we have A times f of x, where the absolute value of A is greater than 1. Well, when that's greater than 1, we'll put J. That is a vertical stretch. Number 8, where we have A times f of x, where the absolute value of A is less than 1, that's going to be a vertical shrink. On number 9, we have f of b times x, where the absolute value of b is less than 1. On this one, we will put C. That is a horizontal stretch. And number 10, f of b times x, where the absolute value of b is greater than 1, we would put B. That is a horizontal shrink. So here's some notes about H, K, A, and B. In the slope-intercept equation, mx plus b equals y, m could be A or B, depending on if there are parentheses around it. And the B is K. There's not an H when the linear equation is in this form, unless, of course, there's parentheses around everything. So for translations, that's when a function moves up, down, left, or right on a graph. Reflections are when a function reflects vertically across the x-axis or reflects horizontally across the y-axis. Dilations is when a function changes its scale factor. It changes its slope. So if we look at this, it has wide to narrow. That's vertical stretching. It's going to be less steep to more steep slope. So in this example, write these in order from least to greatest, not looking at the negative signs. So pause the video, see if you can write this secret phrase down here. Okay, you should get capital P for pull it up. Our P, our 1/2 is the smallest, so that's the widest one. I is next, it's 1, T 3, and then lowercase p would be the 4. Again, we don't look at the negative signs when we're looking at dilations. Now the next one we have narrow to wide. That's also known as horizontal stretching. It will be more steep to less steep slopes. So pause the video, see if you can order this. right here, from greatest to least. This should be your secret phrase. Our biggest number would be 15 over 3, that's 5. So we have 5, and then 2, 1, and then our fraction that is less than 1. One thing about rotations. When the graph turns either clockwise or counterclockwise from a parent function, which is the starting or reference point, when describing transformations.